This is Algebra 2, Chapter 13, Section 3, in which we will study sum and difference of angle identities. What we're going to be dealing with is working on sine, cosine, or tangent of two different angles either being added together or being subtracted. And what we find is we have a sequence of formulas here that will help us find these values. Sine of the sum a plus b is equal to sine of a times cosine of b plus cosine of a sine of b. A lot of people make the mistake here of thinking they can just distribute the sine. It doesn't work that way. Trig functions aren't distributive type things. Similarly, we have a formula for cosine of a plus b. We have one for tangent of a plus b. And then we have one for sine of a minus b, cosine of a minus b, and tangent of a minus b. And what you will notice, I hope, is if you know the plus versions of the formula, then you also know the minus version because everything changes signs. The plus here became a minus. The minus here became a plus. This plus becomes a minus. This minus becomes a plus. So really, if you need to memorize these for some reason, I would just memorize the first three and then change all my signs to get to the second group. When you're working these problems, you're going to want to work with what I like to call the friendly angles. Working with angles like 30 and 45 and 60 and 90 and 180 tend to make our lives easier. Okay. So I'm going to show you kind of how you can use these angles to get things. If they ask me to do a trig function around 15 degrees, well, 15 I could write as 45 minus 30. I could also write it as 60 minus 45. That would work as well. Okay. 75 I can write as 45 plus 30. 105 I could write as 45 plus 60. 120 I could do as 30 plus 90, or I could do 60 plus 60 if I wanted to. And 150 I could do something like 60 plus 90, or I could do 180 minus 30. Okay, the trick is you have to look at these friendly numbers up here and see how can you use a couple of these numbers to generate the number you're going to work on. And we like those values because they keep coming up, so we have an advantage on trying to solve things with them. So let's see if we can find sine of negative 15 degrees. Well, negative 15, I'm sure you would agree, is 30 minus 45. Now I can use the formula from the first slide that you have there on your note sheet, the sine a minus b formula, the fourth one down, says that I get sine of 30 times cosine of 45 minus cosine of 30 times sine of 45. Well, we can get values for those things. Okay. Some of you may have already picked up that every time you do sine of 30, you get 0.5 or you get 1/2. This one you may recognize. We've dealt with it before, square root of 2 over 2. This one is the square root of 3 over 2 that we've seen back in chapter 12. But from here, it's just simple arithmetic. Multiplying, and then subtract the values. Okay. On these kinds of problems, I don't want to just see the final answer. Okay, I want to see your process, how you got there. So just an answer will be just wrong. No work will be no credit. You have to have the work shown on these problems. I don't know how many other ways I can say that, but hopefully the idea has sunk in. Let's tangle with another one. Sine of 75. 75 degrees. I just left the degree sign off. Well, 75, we said, is 30 plus 45. We have the tangent of a sum formula. It's the third formula back on the first slide. So I'm going to put those in. 30 is A and 45 is B. And then I'm going to get my values. Tangent 30, tangent 45, and then again tangent 30 and tangent 45. Clean up some arithmetic and get to our final answer. Again, work must be shown. Okay. They're also going to give you some of these in radians. And when you're working in radians, remember that's going to be things like pi over 3 and pi over 6. You get into a little more heavy lifting trying to figure out where to go with those because of the denominators going on. So my advice to you would be to convert it over to degrees, like we did back in chapter 12, and then use the degree values to work out the problem. That way you don't have to memorize another set of friendly angles and how to connect them. It's easier if they're just in degrees. So that would be my advice to you. Now the last kind of problem we're going to work out here is we're going to verify that something is an identity. Now remember we said an identity is a statement involving trig that is always true. So our job is to figure out, is this always true? It's actually to prove that it's always true. Cosine of stuff is equal to negative sine of x. Well, I recognize this. This looks like two angles being subtracted. This looks like the fifth formula back on slide 1. So I'm going to substitute the 270 and the x as a and b respectively. Cosine 270 I know a value for. It's 0. Cosine x I don't know anything about, so I'm just going to leave it. Sine of 270 is negative 1. Sine of x I don't know. Well, what do we have here? 0 times cosine x is just 0. Negative 1 times sine x is negative sine x. So we have the same thing on both sides of this equation. Negative sine x equals negative sine x. That's true. They are the same thing. So we get to put a check mark to say, yes, it works. And you'll have a few of those on your assignment where you'll be using the sum or difference formulas. Again, those are back on the first slide, and you're going to work with one side and try to get it down to the other. Obviously, you're also going to need to show your work on these because how else are you going to get to the answer without showing some work along the way? So make sure you take care of that. If you had questions as we were going through, hopefully you wrote those down. Bring them into class with you, and we will see you in class.